Welcome to Brain Vision.
For this problem, we have a torsion pendulum that has a metal disc with a wire running through it. The wire is mounted to vertical clamps and pulled taut, and we have two graphs that give the magnitude of the torque and needed to rotate the disc about the center, as well as the resulting oscillations in terms of the angle. And from these graphs, we are able to get that tau equals 4.0 times 10 to the negative third Newton meters. Theta is 0.2 rads, and time at position S is 0.4 seconds. And we are being asked to figure out what is the rotational inertia of the disc about the center, as well as what's the maximum angular speed of the disc. To figure out our inertia, we're going to be using the equation period equals 2 pi square root of inertia divided by torsion, which means we need to figure out our torsion. And in order to get torsion, we're going to use the equation torque equals torsion times theta. We have our theta and we have our torque, so we can rearrange this to solve for torsion, where torsion equals torque divided by theta. So we'll have 4.0 times 10 to the negative third divided by our theta, which is 0.2 rad. So we end up with our torsion equals a value of 0.02. Okay, so now we also need to figure out what our period is. And if we look at the graph here, we see that TS is the length of one full period. So in reality, our period is going to be the 0.40 seconds. So now we have our torsion, we have our period, and we can go ahead and rearrange this equation to solve for inertia. And we'll get inertia equals torsion times the period squared divided by 4 pi squared. And when we plug in our values, we get that inertia equals 0.02 times 0.4 squared divided by 4 pi squared, giving us a value of 8.11 times 10 to the negative fifth kilograms times meter squared. All right, and now we're going to find the maximum angular speed, and we're going to use the equation maximum angular speed equals theta max times the square root of torsion divided by inertia. And again, our graphs here are going to come in handy because our maximum theta, where our highest points here are on this graph, is 0.2 rad. So that does give us our theta max for here. So plugging in the values that we know, we have omega max is going to be equal to our theta max, which is 0.2, times the square root of our torsion, which is 0.02, divided by our inertia, 8.11 times 10 to the negative fifth, which gives us a value of 3.0 0.14 rads per second.